Finding area of a quadrilateral in coordinate plane. This time you'll see the given quadrilateral by proof is a parallelogram, and we'll find the area of that. But first we have to prove it is a parallelogram. Find the area of the quadrilateral in a coordinate plane with vertices A is 2, -1, B is 1, -3, C is 5, -3, and D is 6, -1. First we are going to prove what type of quadrilateral it is before we find the area. So let's find the length of side AB. The slope. Sorry, the slope. First we find the slope of AB. So rise for A is 2 and run is 1. Rise is 2 and run is 1. Now find slope for DC. So rise is 2 and run is 1. So it's -2 going down and -1, which is 2/1. You see the slope is same for AB and DC. Now we find the slope for AD. Just looking at it, it's a horizontal line, so the slope is 0. And then for the BC, it's a horizontal line, also the slope is 0. So they are same slope. So same slopes are parallel lines. So opposite sides are parallel. So this is a parallelogram. Now we have to prove opposite sides are same also. So let's go to our next slide. Now we are going to prove find the sides. So find the length of each side. Side length. So AB. We have going up 2 and right 1. We need to find C. So we know C squared equals A squared plus B squared. To find C, we take square root of everything. So we have square root of 2 squared plus 1 squared. 2 squared is 4 plus 1 squared is 5, so square root of 5. Now we find the side for DC. So 2 and 1, and this is our C. So it's 2 squared plus 1 squared. So it's square root of 5 again. Now we want to find side AD. Let's count our squares since they are square units. 1 square unit, we can count how many squares are there between A to D. So 1, 2, 3, 4. So it's 4 units. And then we find the side length for BC. Let's count our squares. 1, 2, 3, 4. So it's 4. You can see these are same length. And these two are same length. Right? So opposite sides have same slopes and opposite sides have same length. So it's a parallelogram. To find the area of parallelogram, let's look at the formula. So area of a parallelogram is base times height. Now our base, I will say BC is our base. BC is our base, which is 4 units. Now the height needs to be drawn such that it's perpendicular to BC. If we choose point A and draw the line, so our height is 2 units. Point, we can say E. Point AE is our height, which is 2 units. Now we find the area. We find the area. Our base was 4 and our height is 2. So our area is 8 square units. If I say it was a parallelogram, you don't have to prove it, but I said it's a quadrilateral. So what type is it? And then after proving what type is it, then you use the formula for that type of quadrilateral. We can also find the area by breaking into different shapes. So if we break this into different shapes, I can see we have 2 triangles here. And I see I have a rectangle. The rectangle is 3 by 2. So the area of the rectangle is base times height, which is 3 times 2, which is 6 square units. And then we see we have a triangle. Both triangles are same. Base is 1 and height is 2. Base is 1 and height is 2. So area of the triangle is half base times height, which is half 1 times 2, which is 1 square unit. So the area of the rectangle from the previous was 6 square units, and we have the triangles. The triangles area of the one triangle was 1 square unit. So now you have 2 triangles. For 2 triangles, area equals 1 times 2, which is 2 square units. So the total area is 6 plus 2, which is 8 square units. Now there's different ways of doing it. One is breaking into parts, one is using the formula. The other one is you can print out the shapes, and since each square is 1 square unit, you can make whole squares. From the partial squares, you'll see you have total of 8 squares. So it's 8 square units.